Okay, because of the snow days and because of the fact that Monday when you come back to school, you're going to go ahead and have your test for Chapter 8, I'm going to go over some of the questions on the Chapter 8 review with you today so that you can look at them and be prepared, hopefully, for the test that you're going to take tomorrow. I know that we've gone over the vast majority of these in class, but also some of you missed class because of testing with the writing assessment last week. And then obviously we missed Thursday and Friday for snow. So I'm going to go over some of them. But again, like I said, not every single problem because most of these you should have seen before. And I just want this to be a quick refresher for you before the test. So the first problem that we're going to look at here is going to be number 2. Number 2 is x squared minus 6x plus 8. And in the directions it says factor each trinomial using algebra tiles. So the first thing you're going to do every time you're asked to do algebra tiles is you're going to draw your t-bar. And then you're going to consider which pieces and parts you're going to be using. You're going to have 1x squared. So that means that's always our first step. We're going to go ahead and draw in our 1x squared, okay? Always, always, always. That's the first step. Now, I have 8 unit pieces. So I have to think, are my unit pieces going to be 1, 2, 3, 4, 5, 6, 7, 8, or are they going to be 8 out in one row? All right, I can look here and see that I'm going to have negative 6x pieces. So if I were to do my 8s like this, or my unit pieces like this, I would have 1, 2, 3, 4, 5, 6 slots for x pieces. So that lets me know right there that that is the grouping of 8 that I'm going to use. So my next step, 100% of the time, is to come down to the bottom corner of my x squared and go ahead and draw in my unit pieces. And so I don't have to make 8 little boxes. I'm just going to do it like this. And I have 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to draw in my x pieces. Now, one important thing to note here is that my x's are all negative. I have 6 negative x's. So I'm going to show that by shading these in. And this is not my final answer. Now I have to draw whatever comes on the outside of my t-bar, and that's how I get my final answer. So here I have a long side, so that's going to give me 1x. Here I have a short side, so that's going to give me a 1 and a 1. And because it's touching a negative, it means that I'm multiplying a negative. Here I also have a long side, so that's my other x. And then 1, 2, 3, 4 unit pieces. All of them are going to be negative. So I write my final answer over here as x minus 1, 2, and x minus 1, 2, 3, 4. And that's my final answer. Problems 4, 5, and 6 ask you to factor the GCF, or the greatest common factor, from the polynomials. We're going to work number 4 and number 6 for the purpose of this video. So for number 4, all I have to do is look at my factor sheet, and I have to find 5, 10, and 15 all on my factor sheet. So I have 5 here, 15, and then 10 over here. And I can see that the biggest number that all of them have in common is going to be the number 5. So that means I'm going to pull out for sure a number 5. Now, the other thing I have to look at is all of my terms and whether or not they all have the same variable with them, or at least one of that variable. So you can see here I have z to the third, z squared, and z, which also means that I can pull out a z. So here, 5 divided by 5 gives me 1. I had 3 z's, I took away 1, I have 2. Negative 10 divided by 5 gives me negative 2. I had 2 z's. I took away 1, so now I only have 1. And then 15 divided by 5 gives me 3. I had 1 z, and I took it away. I'm done with this problem because all the directions asked me to do was factor out the greatest common factor. Number 6 is negative 55r minus 22. Again, I look at my greatest common factor or my factor sheet, and I find out that when I look at 22, it has factors of 1 and 22, 2 and 11, and then 55 is going to have the factors of 1 and 55 and 5 and 11. So 11 is my greatest common factor between 22 and 55. Because my first term is negative, that means I'm going to factor out a negative 11. Negative 55 divided by negative 11 gives me positive 5. I don't have an r with my second term, so I can't take out my r. And negative 22 divided by negative 11 gives me positive 2. So that is my final answer, and I'm completely done with that again because the directions said just factor out the GCF. The next set of questions say to factor by grouping. I have 4 terms in each of these problems, and they're asking me to factor by grouping. For the purpose of this review video, I'm going to work number 8. All right, when we're asking you to factor by grouping, sometimes it helps to draw these little squigglies because this is what you've seen in class, and this kind of triggers that whole, like, this is your group thing. These are the numbers that you're looking at. This is no different, really, than what we just did in the last 2 problems where we were factoring out the greatest common factors. The first step, again, is going to be to look at my factor sheet. At 3, I have 1 and 3, and at 18, I have the factors 1, 18, 2, and 9, and 3, and 6. So 3 is definitely my greatest common factor between 3 and 18. So I'm going to go ahead and pull out a 3 here. Now, I also have to look at my variable again, and I have w to the third and w squared. So I have at least 2 w's with each of my terms, so I can pull out 2 w's. So here I have 3 divided by 3, which gives me 1, and then w to the third, I took away 2 w's, so now I only have 1 left. Here I have negative 18 divided by 3, which gives me 6. And then I had w squared, I took away w squared, so I don't have any w's left. Here I have 4w and negative 24. So again, I have to go back to my factor sheet and look at my terms of 4. 1 and 4, 2 and 2. And then 24 gives me the factors of 1 and 24, 2 and 12, which 2 obviously is a common factor there. And then continue on 3 and 8, 4 and 6. So 4 is also a common factor and it's bigger than 2. So I'm definitely going to pull out 4 here. And again, I can't pull out a w because there is no w with 24. So 4 divided by 4 is going to be 1. I still have my w. Negative 24 divided by 4 is going to be negative 6. So now I look inside my parentheses, and as long as they match, it means that I've done it correctly. They do match here. I have 1w minus 6 in both sets. So that's my first set of parentheses, 1w minus 6. And then my second set of parentheses is everything on the outside. So 3w squared plus 4. The directions for number 10 through 14 just simply ask you to factor each trinomial. For the purpose of this review video, I'm going to work number 10 and number 12. Okay, I'm starting out with 3 terms. That's why we call it a trinomial. And I know that my rule, when I have a trinomial and I'm being directed to factor it, and I'm going to factor by grouping, I'm going to multiply my first term times my last term, which is 1 times 24. That's going to give me, it's a negative 24, that's going to give me negative 24. So over here, I'm going to list my factors of negative 24. According to my factor sheet, the factors of negative 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now here, I'm looking for terms that are going to add up and give me a positive 2. My final number being positive means that over here, my greatest number is going to be positive. So that means I can just go ahead and make these numbers negative because they're lower than these numbers. And my final sum, when I add them together, is always going to be positive because my lower numbers are negative over here. So I'm going to start at the bottom. Negative 4 plus 6 is going to give me positive 2. That's what I need. So that means that I'm going to break this positive 2 down into negative 4x plus 6x. Go ahead and bring down your negative 24 and your x squared. Now, this problem is exactly like the last ones that I worked. I'm factoring by grouping. I have 4 terms. Anytime I have 4 terms, I can divide them down into 2 groups and go ahead and factor out the greatest common factor. Here I have x squared minus 4x. So I'm going to factor out an x, and that's going to leave me with 1x minus 4. I had 1x, I took away 1x, therefore I'm done. Okay, and now for my second set of parentheses, I have 6x minus 24, so I'm going to look again at my factor sheet and find my common term between 6. I have 1 and 6, 2 and 3. 24 has a factor of 6 as well down here, so that means that 6 is going to be my greatest common factor. I can go ahead and pull it out. So I'm going to say plus 6. 6 divided by 6 gives me 1. I did not take out the x because my negative 24 doesn't have an x. Negative 24 divided by 6 is going to give me negative 4. And what's inside my parentheses here should match, and it does match. So I have 1x minus 4 in my first set of parentheses, and then x plus 6 in my other set of parentheses. So that is my final answer. All right, number 12, again, my directions are to factor the trinomial. So I am going to multiply my first term times my last term, which is going to be 5 times 3, which equals 15. I'm going to write my 15 over here, and then I'm going to go ahead and get out my factor sheet and list the factors of 15, which are, according to my factor sheet, 1 and 15 and 3 and 5. I need the factors that will add up and give me 16. So 1 and 15 are going to add up and give me 16, so that's what I'm going to use. To break down my 16y, it's going to become plus 1y plus 15y. Bring down my 3, bring down my 5y squared. So my first set of terms, I'm going to group with my little squigglies. My second set of terms, I'm going to group with my little squigglies. Here I have 5y squared and 1y. 5 and 1 only have a common factor of 1. Y squared and y have a common factor of y. So when I pull that out, it leaves me with 5y plus 1. Here, 15 and 3 have a common factor of 3. 15 divided by 3 gives me 5y plus 3 divided by 3 is 1. So inside my parentheses, I match. I have 5y plus 1 and 1y plus 3. So that's my final answer for that. Back to our review sheet again. The directions for 15 through 17 say to factor a GCF from the polynomial, then factor the trinomial. So here we're just adding one more step, but we're doing the exact same thing that we've been doing all along. We're going to factor out a GCF first, then we're going to factor the trinomial by multiplying the first and last term and then grouping. So for the purpose of this review video, I am going to go ahead and do number 16. All right, so number 16 is 4s to the third plus 5s squared minus 9s. So if I look at my factor sheet, I can see that 4, 5, and 9 don't have any common factors other than 1. So that means that I'm going to then look at my variable because I know for a fact the directions said to factor out a GCF, so there is a GCF here in these common terms. I have s to the third, s squared, and s. So that means that I can, in fact, factor out one of my variables. So I'm going to say 1, because again, that's my greatest common factor between the three terms, s. And then here, I'm going to have 4s. I had 3, I took away 1, so now I have 2, plus 5s, I had 2. I took away 1, now I have 1, minus 9, and then I had 1, and I took away that 1, so I don't have any left. So that's factoring out the GCF, but what the directions said to do is to factor the trinomial once I factored out the GCF. So at this point, I have to go ahead and multiply my first term times my last term, which is going to be 4 times negative 9. 4 times negative 9 is going to give me negative 36. And then I'm going to look at my factor sheet and I'm going to list the factors for negative 36. It's going to be 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. The key here is that I need terms that are going to add up to give me a positive 5. So just like that little trick I taught you in one of the ones we just did, if my final number is going to be positive, it means that my bigger term over here is always going to be positive. So that means I can just go ahead and make all of these negative instead of having to make them both ways. And then I'm going to figure out which ones I could add together and give me positive, that would give me positive 5. So 4 plus 9, negative 4 plus 9 equals 5. So that's definitely going to be the two terms that I'm going to use. So I'm going to break down my 5s into a negative 4s plus 9s. Then I'm going to bring down my negative 9 and bring down my 4s squared. Now I'm going to look at my groups. Here I have 4s squared minus 4. My greatest common factor between 4 and 4 is in fact 4. And my greatest common factor between s squared and s is going to be the letter s. So here, 4 divided by 4 gives me 1. S squared take away 1s gives me 1s. Minus 4 divided by 4 gives me 1. And then I had 1s and I took 1 away, so I don't have any left. Here I have 9s minus 9. So again, my greatest common factor between 9 and 9 is 9. So 9 divided by 9 is 1. S, I didn't take away an s, so I still have it. And then negative 9 divided by 9 is negative 1. So inside my parentheses, I match. I have 1s minus 1. So that's going to be my first set of parentheses. 1s minus 1. Then, in my second set of parentheses, I'm going to have 4s plus 9 because that's what's on the outside. I'm not quite done yet because I have to remember that in my very first step up here, I did factor out that 1s. So I'm going to have to bring that down. And I'm going to write it right here in front of my first set of parentheses, making that my final answer. For number 18 through 21, it says factor the perfect square binomials. If the binomial cannot be factored, write prime. For this video, I'm going to work number 18, 19, and 21. All right, number 18 says 9x squared minus 25. So what I have to do is get my perfect square sheet over here, and I'm going to look and see what the numbers are that I'm going to multiply in order to get these perfect squares. So here I have 9 as the perfect square of 3 times 3. X is the perfect square, x squared is the perfect square of x times x. So that translates to 3x times 3x. Now here I have negative 25. 25 is the perfect square of 5 times 5. So this breaks down to 5 times 5. Now, all I have to do is put it in parentheses. I have one set of parentheses here and one set here. One has a plus and one has a minus. I know 100% of the time that one has a plus and one has a minus because I'm factoring perfect square binomials, and that is the rule that makes us end up with a binomial instead of a trinomial in the end. So I'm going to bring down my 3x and my 5. And over here I'm going to bring down my 3x and my 5. So one of those 5s goes there, one goes there, one 3x goes here, one 3x goes here. And that's it, and I'm done. 19 teaches us an important lesson about factoring perfect square binomials in that if there isn't a minus sign in between the two, then I can't actually factor it. It's what we call prime. So because there is a plus sign here, this one is simply prime, and it can't be factored. So all you do here for 19 is write the word prime. All right, for number 21, n to the fourth minus 16. N to the fourth is the perfect square of n squared times n squared. And 16, according to my perfect square sheet over here, is the perfect square of 4 times 4. So I'm going to do what I did in my last one, number 18, that I could work and set up my two sets of parentheses and go ahead and put my plus and my minus sign. Now I'm going to bring down my n squareds and my 4s. I'm almost done here, but while this one is prime because it's got a plus sign, this one is actually still able to be factored because n squared is the perfect square of n times n, and 4 is the perfect square of 2 times 2. Again, if you're not sure, just look over here. On your perfect square sheet, it tells you. So that means that this has to break down again. So again, I'm going to do my two sets of parentheses with my plus and my minus sign. I'm going to bring down my n's and bring down my 2's. Now, keep in mind, this prime one from up here, I've got to bring that down too. So this final answer has 3 sets of parentheses in it, and this is fully factored here. Number 22 through 25 say to factor the perfect square trinomial. So we just factored binomials, and now we're going to factor trinomials. For the purpose of this video, I'm going to do number 22 and number 25. So for number 22, again, I'm going to go back to my perfect square sheet, and I'm looking initially at just my first terms. So here I know that m squared is the perfect square of m times m, so I can go ahead and break that down. I know that 81 is the perfect square because I'm looking at my perfect square sheet of 9 times 9. So I'm going to break this down into 9 times 9. Now there's a special rule here that makes us different from factoring binomials, in that I have to look at my middle term and figure out if this shortcut that we use is going to work. So in order for this shortcut to work, it means that I have to multiply 2 times one of my first terms, which is m, times one of my second terms, which is 9. And that has to give me that middle term in order for it to work. So 2 times m is 2m, and 2m times 9 is 18m. So that does work. Put a little check mark there so I know that I'm able to move forward. Now I'm going to set up my 2 sets of parentheses. Again, there's a really slight difference in this step than there was from factoring binomials. Here I look at this sign. The first sign, the second sign is always going to be positive, but this sign, if this sign is negative, it means that there's a negative in both sets of parentheses. So I'm going to bring down my m's and bring down my 9's. And now I'm done with this step. I could also write my answer as m minus 9 squared. Either way is correct. All right, so number 25 is going to work pretty much the same way. The first thing I'm going to do is look at my first term. I have 16a squared. So I know that a squared is the perfect square of a and a. I can look at my perfect square sheet and see that 16 is the perfect square of 4 and 4. So I'm going to break this down into 4a times 4a. And then over here, I'm going to look at my last term. I know that b squared is the perfect square of b times b. And according to my perfect square sheet, 25 is the perfect square of 5 times 5. So I'm going to break this down into 5b times 5b. Now, I have to check my middle term. I have to multiply 2 times one of my first terms, which is 4a, times one of my second terms, which is 5b. 2 times 4a is going to give me 8a, and 8a times 5b is going to give me 40ab. So this does give me 40ab, so that checks out. So here I'm going to bring down my 2 sets of parentheses, and I have 4a and 4a, 5b and 5b, and I'm going to look right here at my sign, which is a plus sign, so it means that there's going to be a plus sign in both sets of parentheses. So again, I could rewrite this as 4a plus 5b squared. In the event that you had issues with any other problem on the review other than the ones that I worked in the video, I wanted to go ahead and show you the answer key here. If you have specific questions about how to work a problem, please post a comment on the Google Classroom message board, and I will be happy to help you with that specific problem. I want you prepared for this test tomorrow, no matter what. So please just let me know if you're having issues with a specific problem. Okay, pause the video if you still need these. I'm going to move on and show you the rest of the answers. All right, this is the end of your video. Thank you for watching.